Okay, so hopefully we've gotten some of the technical difficulties taken care of that were causing some trouble here with volume. But this lecture is, this problem set is about fiscal policy, and it's our second one. So this one's going to be examining the multiplier. And the first question says, would the multiplier, and we could say the spending or the tax multiplier, either one, be larger or smaller if households saved more of an increase in their income? So what the second part is saying, this portion is saying, is that the change in savings over the change in disposable income, that people are going to save more of that. And this value is the MPS, and so that would tell us the MPS is going to get bigger because the numerator is getting larger. Now, this question is about the multiplier, not about the MPS, and the multiplier is 1 over MPS. And so if MPS is getting larger, then actually the spending multiplier is going to get smaller. And so the multiplier gets smaller as people save more. Question 2 says, what would be the multiplier if every household saved all of an increase in their income? In other words, that you have this change in savings over change in disposable income. And that is the idea that we're saying this is the derivative, for the mathematically inclined, the derivatives of your savings function. That if you had a function that relates your income and your savings, the derivative of it would yield this function. And the multiplier, if people saved all of their income, that means that these two values are the same. And so the MPS is equal to 1. MPS is equal to 1. And so the 1 over 1, which is the MPS, is also equal to 1. Now this would be the spending multiplier. What would be the tax multiplier if people saved everything? Well, you would get one less round in the tax multiplier, and so we'd say the tax multiplier would be 0. Now let's take a look at the multiplier if every household spent all of an increase in their income. Well, in this case, the change in savings is 0, and so it's over a disposable income. So 0 divided by something is just 0. So MPS is equal to 0. Now we've got 1 over 0 for our spending multiplier, which is undefined. Now, this is a computational problem that we would resolve here with calculus, and we'd actually find that ultimately it becomes an infinite increase, a infinite multiplier, because the idea here is that if you increase if I paid you $100 and then you spent all of that $100 and the next person spent all of the $100 and so forth and so on, that ultimately there would be an infinite multiplier because everyone spends the full amount every time. Okay, now let's take a look at the multiplier table here below, and in it you're given some MPCs and MPSs and then asked to solve for an SM and a TM. So first we know that MPC plus MPS is equal to 1. So for this first one, 0.9 plus 0.1 has to equal 1. For the second one, 0.8 has to be the MPC, then 0.25 MPS, 0.67 MPC, 0.4, 0.5, 0.67, and 0.25. Now the spending multiplier is just 1 over the MPS, and the tax multiplier is 1 minus the spending multiplier. So now we just take this value in the MPS column and we put it as the denominator in a reciprocal here. So this one is 10, and then 5, 4, 3, 2.5, 2, 1.5-ish, and 1.3-ish. Now with these, the ones that are decimalized are highly unlikely you'll see on an exam. You're most likely to see nice whole integers be your spending multipliers. But now we can do the tax multipliers either way. 1 minus this 10 is -9, then -4, -3, -2, -1.5, -1, -0.5, and -0.3. And now we're going to fill out the rest of this problem set with some of this information. The numerical value for the investment governed spending multiplier, so the spending multiplier, increases as the value of blank propensity to blank blanks. So spending multiplier increases. That's moving up at this table. So we could actually answer this in two ways. We could say the marginal propensity to consume, the MPC. All right, so spending multiplier increases in this column as the MPC increases. So we're just kind of looking at these two columns. You could have alternately said the marginal propensity to save, so this column, as the MPS decreases, because either one of these would fit. Now, the next one, if the government spending multiplier is 5 in Clayton, the value of the tax multiplier, well, that's just 1 minus 5, so -4. government spending multiplier for Clayton. Now this one is a separate problem. Students all day have kind of pointed that out to me. I should use some different names here. The government spending multiplier for Clayton is blank, and you have to do it from this data table. So the first thing we have to figure out is MPC, which is equal to the change in consumption over the change in disposable income, and that's what we're given as consumption and income. Then we'll use that to figure out the MPS, and then we'll use that to figure out the spending multiplier, which is 1 over MPS. So the first step is change in consumption, and that you can choose any pair of numbers. So like you could choose that pair and that pair. You could do 500 and 600 and 450 and 525. You could do different pairs like 100 and 600 and 150 and 525. Doesn't really matter. We'll just pick the bottom one. So 450 to 525 is 75. That's the change in consumption over the change in income, which is 100. And this is our MPC that we're looking at. So here we have 0.75 MPC, which means that the MPS is 0.25. 0.25, because if you add these two values together, you get 1. Now, spending multiplier, SM is 1 over 0.25, so that is 4. Okay, next part. If there's an increase in taxes of 200 in Clayton, the decrease in GDP will be blank. So we're using this value here, and we should know that if the government spending multiplier is 4, then the tax multiplier is 1 minus 4, is negative 3. So increase of taxes 200 times 3 is 600. And it already says there's a decrease in taxes, or a decrease in GDP, so we just say 600. Last part, if there's an increase in government spending of 100 and an equal increase in taxes of 100 in Clayton, then the change in GDP will be what? And this one's actually a trick question. You could just write 100 and be done, but the explanation is a little bit harder. Now, a lot of students will want to say 0 because they think that these two things cancel each other out, but they don't, and here's why. So let's use the spending multiplier and tax multiplier that we just calculated to prove this. 4 is our spending multiplier times a change in G of 100, and it's an increase, plus our tax multiplier was negative 3 times an increase in taxes of 100. And what do we have? We have positive 400 here, and we have negative 300 here for an overall increase of 100. Now, like magic, you could actually swap in any spending and tax multiplier, right? You could do 10 and negative 9, and this would be 1,000, that would be negative 900, and you'd end up with 100. Why? Well, the answer why is not so much locked in that it's 100. In fact, if this were 50, this were 50, then this would be 50, right? It'd be the same answer. And the why is because the tax multiplier is one less round of multiplication than the spending multiplier. And the idea is that the initial event, right, the rock that gets thrown in the pond, is the government spending and the tax change. But the initial rock, the only thing that affects GDP is the government spending. The tax change doesn't affect it. So you end up with no effect in the first round from the taxes, but you do add 100 from the government spending. And then in the subsequent rounds, all of the multiplied kind of aspects get canceled out. So all you're left with at the end is the increase of government spending. So again, if you're given these types of problems where it says there's an equal increase in taxes, or they finance the government spending through an equal increase in taxes, what they're saying is just use the initial number. Okay, so hopefully this helps you with fiscal policy practice problem set 2. I'll see you next time.